So now we're going to find the arc length of a curve. So here I have y equals 4x cubed plus 3. If x is 0, y is 3. If x is 4, 4 squared is 16, times 4 is 64, plus 3 is 67. So here's a rough sketch of that parabola from its vertex up to this point, 467. So we're going to find the arc length here from 0 to 4. And it turns out we're going to need a special formula for that in a moment, but let's just set it up. I need to know what dy dx is. 2 times 4 is 8. X is the antiderivative. And so I'm going to have, for my arc length here, the integral as x goes from 0 to 4 of the square root of 1 plus parentheses squared, inside goes the 8x. All right, so this doesn't look too bad as far as functions go. However, its antiderivative is a bit complicated, so I have the formula for us right there to use. So I'm going to plug it in here. So then antiderivative with a equals 8 in this case is going to be that original square root of 1 plus the square of 8x times an 8x outside the square root, plus the natural log of, I'm going to put an extra parentheses there for fun, absolute value, again, that square root of 1 plus the square of our derivative 8x. And this time in here, I get a plus 8x. Close the absolute value, close the natural logarithm, divide all of that by 2 times a, which is 2 times 8, or 16. And we're going to evaluate that from 0 to 4. All right, next, let's check that out on a calculator in a couple of different ways. So I have Desmos set up here with my graph, 4x squared plus 3, and we're going to graph between those 2 points, where we want to find the arc length. Here I've entered my antiderivative as a function, so I have 1 plus the square of 8x times 8x, and the natural log in Desmos needed a parentheses. If you just try to do the absolute value, it's going to freak out on you. Found that out earlier. Plus my 8x, all inside the absolute value, which is inside the natural log, divided by 2 times 8, or 16. And I need to know here what is a of 4. So that's 64.29-ish. There's no guarantee that plugging in 0 gives you a 0. So let's just check a of 0. Looks like it would have been 0 on its own. Just double check. Yeah, okay, so just to be careful, though, we want to type it like that. So there's the evaluation of our antiderivative from the endpoints. And to double check that we have the right antiderivative, we should also do a little numerical integration on that. So x goes from 0 to 4 of parentheses, the square root of 1 plus parentheses 8x squared. And yes, that should be a plus, not an equals. Yep. Close the integrand, and then let the computer know what the variable of integration is. And I get the same value. So we think that arc length, then, if all is well, is around 64.